This lesson is going to cover standard form of a linear equation, and it hopefully will be a much shorter lesson than some of the more recent lessons that we've done. So up until this point, we've really only looked at one form of a linear equation. And when we talk about a form, what we mean is the way that the equation is written. So the form that we've covered is what's called, I don't know what his problem is. There's the cat. Slope-intercept form, which is also known as y equals mx plus b, because the m is the slope and the b value is the y-intercept. And I usually call this like everybody's favorite form of the equation for a line. It's just a really nice and convenient and fairly simple form to work with. You might also see this you might see an A instead of the M, and it's the same thing, okay? So if you see it, I know some graphing calculators will have an A there, and all they're doing is they're just going in alphabetical order, so they're starting with the letter A and then moving to the letter B, okay? And it's exactly the same thing, so if you see that, that's what it is. Now, standard form for the equation of a line is this, and there's a couple of variations on this, and I'll try to address that, okay? So, hang on. Okay, sorry about that interruption. I let my cat out. Now he'll start meowing from the other side of the door. So standard form, there's a couple of variations on this, and I do want to address that. So I think that's where I left off. So standard form is this. It's A times X plus B times Y equals C, where, okay, A, B, and C are integers. Okay, and remember that integers are these numbers here. Okay, so positive and negative whole numbers. Okay, so that's what you're talking about. Now, and the B value here is not necessarily the same as the B value over here, okay? It's like a totally different form. Now, I have also taught from curricula that say that, we'll put this in parentheses, A must be positive, okay? So they won't let you leave this number right there as a negative number. Not all curricula will say that, so there is some flexibility in that, and if you're watching this video to supplement whatever you're doing in class, in an Algebra 1 class or an Algebra 2 class, you want to make sure that you know exactly what version of that definition and what specifics are going to be required in your class from your teacher. So there is a little bit of variation there. So most of what we're going to be doing here is going from slope-intercept form into standard form, just kind of working through the mechanics of changing the form. And an experienced mathematician, somebody who's done math for a long time, will recognize, like, if they see an equation in slope-intercept form, they automatically know that it is linear. And that if they graph it, it's going to be a line. And the same with this. Like, you see an equation and it's in that form, then it's a line. And later in this course, we'll get into some equations that aren't lines. And so when you go to build your table and plot your points, you end up with some shape other than a line. And then when you take Algebra 2, you actually study lots of different kinds of equations that look different ways. So let's take a look at, what's the problem here? We'll do y equals 2/5 x minus 3. Okay, and that, of course, is in slope-intercept form. It's got a y-intercept of -3, a slope of 2/5. Slope-intercept form is usually the form you want it in if you need to graph it. Okay, that's, in fact, people will take equations in other forms and they'll put them in slope-intercept form because it's easy to graph. But we want to get this so that it is some number times x plus some other number, I didn't mean to make that purple, but times y equals, we might as well keep changing the colors up, equals some number c. So what we're going to do is just some algebra steps to juggle this around. So the first thing that we want to keep in mind is that a, b, and c are integers, which means they can't have a denominator, or the denominator would be 1. So that means that denominator of 5 is problematic. We cannot have the denominator of 5. So I want to remind you that 2 over 5 is the same as 2 divided by 5. And the way we undo division is through multiplication. And so if I have 2 divided by 5 and I don't want to have that divided by 5, my solution to that is to multiply by 5. Now, we cannot just multiply one piece of an equation by 5 because that is going to make it I'm trying to do a multiplication sign there. There we go. That's going to mean that the equation is no longer balanced. That equal sign is probably the most important symbol that we have in math, saying that whatever's on the left is equal to whatever's on the right, okay? So right now, we're just multiplying that one little piece by 5. So you might say, oh, well, then we'll just multiply the left-hand side by 5, which is closer, but still not where we want to go. Because over here on the left, the entire left side is being multiplied by 5. On the right, I have some of it being multiplied by 5 and some of it not being multiplied by 5, which means I'm not really doing the same thing to both sides. This side is getting like more multiplication than this side is. So to keep it balanced, we have to multiply everything by 5. Okay, so now we've got 5 times y is 5y. Right here, if you take 2, divide it by 5, and then multiply by 5, the dividing and the multiplying are going to cancel each other out and leave you with 2. You can also do it this way, where you would multiply the fractions and you'd get 10 over 5, and 10 divided by 5 is 2. Okay, so that also works, whichever way is more comfortable for you to think about. And then we have minus 15. So I'm closer to this form because now I've cleared the fraction. Now I need to have that x value on the left-hand side. Right now the x value is on the right-hand side. So in order to move it over here, I'm going to basically subtract it, and I'm going to subtract it from both sides. So that gives me 5y minus 2x. And then over here, 2x minus 2x is 0, leaving me with negative 15. I'm almost in the right form, except mine are out of order. I need to have the x first and then the y. So I'm going to switch this. Now, I often will just tell my students, when you go to switch the order, make sure to retain the signs, okay? So the negative 2x was negative, so it needs to stay negative. The 5y is positive, it needs to stay positive. Other people might describe it this way. They'd say, hey, remember that subtraction is really plus negative, and then you can use the commutative property. Now, some curricula will accept this as being in standard form. So I'm going to go ahead and box it in. But if you have that requirement that the a value must be positive, then you need to think, okay, well, how can I make that positive? If I were to multiply this by negative 1, okay, that would make it positive. Because negative 1 times, that is a negative 2. Let me try it one more time. Okay, negative 1 times negative 2 would give you positive 2. But just like right here, you can't multiply like a piece of it. If you're going to commit to multiplying by negative 1, you've got to multiply everything by the negative 1. Otherwise, you're not doing the same thing to both sides. And then when we multiply that, we'll get 2x. Now you have negative 1 times 5, which is negative 5y. And then on the other side, negative 15 times negative 1, which is positive 15. You might say, ooh, look at that. Whoops. Right? You might look at that and then think, oh, we just flipped the sign of everything. So negative became a positive, positive became a negative, negative became a positive. Yep, that is actually what multiplying by negative 1 does. So just pay attention with that, know what the rules are for your class and what you're expected to do, whether or not you're allowed to have that negative value in front of the x, because I have seen that different ways and I've actually taught it different ways. All right, let's look at another example. Suppose you had a more realistic equation that had like horrible numbers in it. And this time we'll make that negative. We're going to try to put this in standard form. So there's two ways you can think of this. You can think of this as a problem where you just need to move the decimal point. And so depending on how comfortable you are with your decimal values, you know that if you were to multiply this by 100, it would essentially move the decimal point over, it would put the decimal point right there, and it would give you the 135 because we're base 10 numbers, and so multiplying by powers of 10 just moves the decimal point. The other way you could think of it, which kind of ties it into what we were just doing, is you can think of what this number is. This is 55 hundredths, and so you could write it as a fraction, and this is 135. Sorry, it's not writing the way I want. Hundredths, okay. Or you can just do it this way. Where we're going with this is that basically you're going to multiply by 100. Okay, so we're going to take the left side and multiply it by 100. And the reason we're doing that is to try to clear out that fraction or move that decimal point. Okay, so multiplying by 100 is just going to kick the decimal point over. So now I've got 100y. And then here, the hundreds cancel out, leaving you with the negative 55. And here, the hundreds cancel out, leaving you with the 135. And we're not quite in standard form yet. We do need to move our x value over to the other side. We need to get it away from the right side and put it over on the left side. So we'll add 55x. And then I'm just going to write this in the correct order. So we'd have 55x plus 100y equals 135. Now, you might notice that there's a common factor of 5. Like all of those numbers there can be divided by 5. And that's certainly something that you can do. So if you wanted to kind of shrink your numbers down, you could divide everything by 5. Just remember that whatever you do to one side, you have to do to the other side. And so this would give us 11x plus 20y, and I believe that is 27. So either of these would work. This would satisfy standard form, and I keep grabbing the bottom of the screen and moving it, and it keeps pausing the video, so hopefully it edits together okay. And so there's our standard form for that line. Now, where you see standard form a lot of times is in word problems, which I know everybody loves, but there's a lot of situations that just kind of naturally lend themselves to word problems here. So I'm going to upload a picture of a word problem kind of example that you might see. All right, so what we have here is a linear model for buying party food. So you are in charge of buying the hamburger and bone chicken for a party. I'm a vegetarian. That does nothing for me. You have $30 to spend, and you are going to the kimchi grocery store. Write an equation that represents the different amounts of hamburger and chicken that you can buy. Okay, so we actually need a little bit more information here, and I did not photograph that. Let me see if I can get that other piece of information on here. All right, well, not my greatest editing job ever, but at the kimchi grocery store, hamburger costs $2 per pound and bone chicken costs $3 per pound, okay? So you did need to know the cost of the hamburgers and the chicken. So so here's how you would take that and put it into an equation, okay? So you've got like hamburger plus chicken equals like the total money, okay? So the cost of the hamburger plus the cost of the chicken equals the total amount of money that you have to spend. So the total amount of money that we have to spend is the $30. So whatever the cost of the hamburger is and the cost of the chicken is, that has to come to $30. Now, the cost of the hamburger, we are told, is $2 per pound. So if I take $2 and multiply it by the number of pounds of hamburger that I have, that would give me the total cost of the hamburger. Chicken costs $3 per pound. So if I take $3 and multiply it by the number of pounds of chicken, then that would give me the total cost of the chicken. And you'll notice that this is in standard form. So 2h plus 3c equals 30. And a lot of times in your word problems, you will use letters to represent whatever it is. So I used H for hamburger and C for chicken, so that when we get to the level where you're solving a system of these, you know what the variables represent. But if that makes you antsy, you can always go with X's and Y's. Okay, both of those would be the same. So that pretty much wraps up our lesson on standard form of linear equation, and I will give you guys some practice problems to do, and then of course do them out, and then unpause the video to check your work. Okay, 6 quick problems. Write in standard form 3x minus y minus 6 equals 0, y plus 4 equals 0, y equals negative 1/8 x plus 3/8, y equals 0.4x plus 1.2, and the equation for the line that goes through negative 4, 3, and has a slope of negative 1. And then write the equation that would describe this situation here. You are buying $24 worth of peanuts and cashews for a party. The peanuts cost $3 per pound and the cashews cost $4 per pound. Write an equation for the different amounts of peanuts P and cashews C that you could buy. Pause the video, work these out on your own, and then unpause to check your work. All right, here we go. So the first one, you have 3x minus y minus 6 equals 0. And you don't want to get thrown off just because the format of the problem looks a little bit different from the ones I did in the lesson. The concepts are still the same. And where you're trying to get to, that ax plus by equals c, is still the same destination, and there's nothing in this problem that we haven't covered in an earlier video. So in order to get it in that form, it's the 6 that's causing the problem. So you have the x and the y on the left-hand side, but you don't want the constant over there, and so you need to add 6 to both sides. So you end up with 3x minus y equals 6, which is an acceptable answer. If you want to put the integer there, then you might put the 1 just to remind yourself that that's a 1y. Okay, to get that integer, but otherwise you're fine. Y plus 4 equals 0. Again, don't be thrown off by the fact that it looks different. So you've got the y on the left. You don't want the constant on the left. The constant needs to go on the right. So we'll subtract 4 from both sides, and we get y equals negative 4. Now, technically, that satisfies this, but you're probably wondering, wait a minute, what about the x? And there's just too much missing here. Here's what it is. So remember, we're trying to get to ax plus by equals c. So what we have there is 0x plus 1y equals negative 4. And the a value in front of the x is actually a 0, because 0 times x would be 0, and it would cause it to drop out. And then, of course, we don't have to write the 1 there, so we end up with just y equals negative 4. So this might make you feel a little bit more comfortable because you can see the form better. Just know that the 0x drops out and the 1 we don't need to write, and so it actually condenses, so y equals negative 4. Number 3 was more like the ones that I did in the presentation of the lesson. So we want to clear that fraction, so we'll multiply everything by the denominator to try to clear the denominator out. That's going to give us 8y on the left, negative 1x, and then plus 3. Then we need to get the 1x over to the other side. You can write the 1 in front of the x, or you could just write x plus 8y equals 3, and it would be understood that the coefficient was the 1. Okay, so either one would be fine there. And then as always, if you need to pause the video to correct your work or make some notes in your own work, please go ahead. Okay, next one had the decimals, and these were tenths, so that's 4 tenths. So it might be, if you're a little bit more comfortable looking at the fraction, looking at it like that, and then 1 and 2 tenths. And so the number that we want to multiply on this one is the 10. So we get 10y. Multiplying by 10 is going to move that decimal point one spot over to get 4x, and then one spot over to give us 12. And then we subtract 4x from both sides. So negative 4x plus 10y equals 12. That is an acceptable form. Or if you're in a situation where you have to have that leading coefficient there that it has to be positive, you can multiply everything by -1. And so -1 times -4 gives you +4. -1 times 10 gives you -10. And -1 times 12 gives you -12. So either of those forms is fine. For the next one, we actually have to go back and review some skills from earlier. So we have to be able to write the equation in slope-intercept form first and then change it over to standard form. So we're borrowing the point. We borrow the 3 for the y. We borrow the -1. We're not borrowing the -1. That's there to stay for the m, but we are borrowing the -4. And then we're looking for the y-intercept. -1 times -4 is 4, and then subtract 4 from both sides to isolate the b, and we end up with b is -1. So the equation would be y equals -1x minus 1. That's in your y equals mx plus b form. And then we'll move the 1x over by adding 1x to both sides. So you have 1x plus y equals -1, or you might just write x plus y equals -1. Same deal as on the previous page where like you don't have to, like the 1 kind of disappeared there. But you don't have to write the 1, but it's not wrong to write the 1. So don't erase it or anything if you wrote it. If you wrote it and you're comfortable with it, then stick with it. And then the last one are nuts for our party that we're having. So we're having hamburgers, hot dogs, and then cashews. So the cost of the peanuts plus the cost of the cashews will give you the total cost. $3 per pound times the number of pounds of peanuts. Plus $4 per pound times the number of pounds of cashews, and that's got to equal 24. And so you should have 3p plus 4c equals 24. If you wrote this, 4c plus 3p equals 24, that is also fine because we don't really have the x and the y in this problem. And they're both integers, so that would be fine. Like switching the order of the addition doesn't matter. So this was a little bit shorter video compared to some of the ones we've done recently. Probably a relief. So there we go, standard form of a line, and I'll see you in the next video.